And if I change, and now is it better? Okay. What can I do to change this? Okay. And now? Okay, it seems it's better. Okay, good. Sorry for this small issue. Okay, I'm gonna do the introduction again. So thank you for joining us today. It's the part 2 of the Airflow Alternative Meetup. Today we're gonna have Jeff and Tim from Prefect and Dagster. I'm happy to have this part 2 of the meetup to see other alternative of Airflow. I will do a small introduction of the meetup and the event, and then I will give the floor to Jeff. So this meetup is organized by the Paris Apache Airflow meetup. This is a local meetup based in Paris. And the goal of the meetup is to animate the Parisian-based and French-based Airflow community. The goal for 2023 is to organize one meetup per month. We are like a big team of 5 people, 5 co-organizers. This meetup is online, but usually we do it like in French and with local events. But as like all the Airflow alternatives are mostly based outside of France, we decided to do it online and in English because it was like easier logistically. Just a small ad, we are still looking for speakers for the next event and for host. When I say host, it's like host based mostly in Paris. So if you have like speaks and presentation you want to do about Airflow, reach out to me or to the organization team. Even and also same for the host. Just to put in the context, over the years, more and more tools were developed to orchestrate and schedule data work. And to be honest, it's hard to navigate between what's available. There is like the flagship that is Airflow, to be honest, and then there are like other alternatives. And each time when we do offline events, we get questions about how does it compare to this, and that was the reason we decided to do this Airflow alternative meetup. And when we look at the numbers, this is something I already shown 2 weeks ago. Here, survey that Seattle Data Guy did a few months ago. We see that Airflow was the most used orchestrator in his community, and Prefect and Dagster are coming 3rd and 4th. And this is cool because today we're gonna have like a presentation from them. That's all for my introduction. I will give the floor to Jeff. So Jeff, yeah. Hello, Jeff. How are you doing?
Hello, can you hear me okay?
Yes, I hear you well.
Excellent. Thank you so much for the nice introduction. I will share my screen here and get started.
Yes, go on.
Screen.
So for the logistic, you have like half an hour, something like this. You can have 20 minutes of presentation. It depends on how long you want, and then we're gonna take questions from the chat.
Great.
Yeah.
Awesome.
I will put your screen as a presenter, and you have the floor.
Awesome, thank you. And I think I can see questions also too. I'm not sure if I can necessarily respond to those in real time, but we will try to address any questions you might have. All right, well, welcome everyone. As Christoph said, I'm Jeff Hale with Prefect, and I'm going to be talking about our tools for dealing with complex systems, which is what we're increasingly finding ourselves with in today's world. So we think of Prefect now as a company that makes tools for interacting with these complex systems. I am mostly going to be talking about our Prefect open source and cloud product that gives you a flexible and scalable Python data orchestrator and is really great for observation. But also within the past week or two, we've had a very interesting experience where an open source product that we released named Marvin, which is a batteries included library for building AI powered software, kind of really took off. We went from I think I was the 3rd star last week on Tuesday or Wednesday, and now we have about 1,300 GitHub stars last time I checked a little bit ago. So it's a product that's really starting to resonate with people. And really, as we'll see, these are kind of two sides of the same coin for dealing with these complex systems that we find in our world today. So let's talk about the data orchestration side of things here. We want to emphasize that Prefect is flexible and scalable, and it is really built around Python. It's all about Python and helping people use and orchestrate their data. So just a quick picture here. What do things look like? I like to give people a little bit of context as you have an image in your head as you think about what's going on. This is a UI from our cloud, screenshot of our UI, showing a timeline view of flows being run and some of the different things that we can do with those. And we'll talk about those as we go. All right, briefly about me. I'm a developer advocate. I like to teach, write, organize events around Prefect. And also I am the organizer of the Data Science DC Meetup. So Christoph and team, I feel all of your pain and appreciate all that you do to make these kind of events happen. I know there's a lot that goes on behind the scenes. I'm also a board member of Data Community DC, which organizes and oversees a group of nonprofits. So very, very into this scene. All right, so apologies in advance, but Marvin, our AI assistant, is going to help me out with a few bad puns as we go here. So anytime you see this light blue screen, you might just want to run and hide. But first one that Marvin spit out here is, why did the data scientist break up with her boyfriend? Because he couldn't handle her discrete values. Does it totally make sense? Maybe not, but that's sometimes what we get with AI. All right, so back to orchestrators here. So workflow management, orchestration, we're going to kind of use these terms as interchangeably here. And to quote our CEO, Jeremiah Lowen, who introduced this idea when he introduced Prefect in 2018, I have some tasks I need to make sure they happen, right? Presumably most folks are here and kind of aware of what we're going for with an orchestrator. But if not, just want to get us all on the same ground. And a related quote here from Werner Vogels at the AWS CTO, everything fails all the time. If everything just worked all the time, we wouldn't have a need for orchestration and observation, and all of us would have a much easier job. But the reality is that things are often not doing what we hope they will. So we want to give some observation through things like logging. We have UI visibility, automatic retries, notifications, caching, so we don't have to rerun things if that's not necessary. Scheduling, that's a reason a lot of folks get into orchestration and workflow management. And now more and more we're seeing event-driven workflows as things that people really want, and trying to be ready for that world is something that we all have needs for. So this is one way that we conceptualize kind of a spectrum from observability to orchestration, where we have maybe more passive things where we're just kind of observing what's going on the left, my left at least. And on the right, we have more kind of involved things that take some more active orchestration. Maybe we think of those as more orchestration events. And a lot of the times these orchestration events depend on having the observability so that we can actually react to things in real time. So this is just kind of one way to help orient yourself around some of the things that orchestrators and Prefect in particular offer to try to help us manage the complexity in the world around us. All right, a little bit of background here about how Prefect came to be and kind of shared history with Airflow. So Jeremiah Lowen was a data scientist and data engineer working mostly in financial and risk management spaces, and had a need for a product like Airflow, got involved, was a user with the product, and became quite involved with contributing to the project. He actually helped port, primarily, this was the thing he did when he started, was, hey, can I port it to Python 3 from Python 2? So history there goes pretty far back. He was a former Airflow PMC member, wrote XComs, so he was trying to solve a problem where he wanted some tasks to have a little bit of knowledge about what was going on with other tasks, and kind of really made data handling more important, but still often a little misused today in Airflow. So at one point, I think Jeremiah had the second most commits on the Airflow project, so definitely very involved there. And then he started to see an opportunity and a need to scale Airflow to bigger projects and really treat data in a first-class way and have an easier, just get started with kind of experience for people who wanted to do data orchestration. So we started Prefect. In 2018 is when it kind of hit the scene with the PyData talk in Washington, D.C. And in 2019, Prefect was released, and kind of taking everything that we had learned from 3 years of feedback and just lessons along the way, we released Prefect 2.0 this past summer in 2022. All right, so Prefect today, we have our open source library, and we also have a cloud platform with it. And now we have Marvin, the AI assistant area code, which just popped out last week. And we have a strong and growing company. I was looking at those stats from Seattle Data Guy there, where Prefect was about 5.5% of users reported in that survey. And that survey is times change fast here. So when I was looking at downloads of Apache Airflow and Prefect and other packages, I saw that Prefect was over 10% of Apache Airflow, and definitely an increasing trend there. So we are definitely growing in the space. A couple other stats for you. We have over 1,000 GitHub forks of our Prefect library, over 10,000 GitHub stars, over 20,000 community Slack members. Feel free to join there if you got questions, want to get more involved at prefect.io/Slack. And over 200,000 weekly downloads. It was over 250 when I checked yesterday for the past week. And over 2 billion cloud task runs. So that's across Prefect 1 and Prefect 2, and that number is also a few months old now. So huge amounts of folks using the product and running tasks on it. All right, let's chat about features here briefly and some benefits. So scalable and flexible, right? We said that's part of the DNA of Prefect and why Prefect was invented. The observability piece is something that we think is just more and more important, and we're really leaning into that and trying to be ready for event-driven workflows and really have ways to orchestrate with those are things we're doing. So scalable, you can run and observe thousands of flows in the UI. We've got a YouTube video that just dropped last week with Ray and Anyscale folks. And I got a link there that I can share in the chat, or also share these slides if folks want them. And a customer of ours, LiveEO. And this is just one screenshot that, you might be like, wow, what is this? The Northern Lights here? What's going on? These are all individual task flows in a timeline view. And you can zoom in and click on those and see how they relate to each other and follow all of the dependencies. This is from a user of ours, and they were quite impressed that this several thousand task view was able to be visible in the browser and work just fine. So definitely meant for that kind of scale. Flexibility. So Prefect allows you to just bring your Python code and add a few decorators, as we'll see in a moment. And it works with Python even 3.11 here. This is a subtle, not so subtle mention at Airflow, where 3.11 portability isn't here yet. I think we had it ready to go within a week of the release. So we do try to release things quickly and be on top so that people can use whatever Python tools they want and get the latest and greatest in their in their code and in their workflows. In terms of flexibility, we think DAGs are great. They work really well in a lot of workspaces, especially if you're kind of doing a schedule, regular interval type of pipeline, which is fine. But they can also sometimes be restricting. So Prefect doesn't require any predefined DAG. You can have any kind of branching control flow structure you want, and we just try to be really flexible for folks, no matter what the workflow is. DAGs are fine. We can use DAGs, but also you can do whatever you want. In terms of observability, we've got logging in the command line and interface, and also in the UI. We have a nice timeline view, so you can work and see everything that's happening. And you can do it with your collaborators. So this is a nice advantage of having Prefect Cloud. We make it easy to have your teammates involved and let them see what's happening in your workspace. And then notifications, of course, that's something that's very easy to set up and gives you all kinds of ways to get notified if something goes well or if it doesn't go well, depending on what you want to see. So again, here's just kind of what things look like in the UI. And we're just fetching some cat facts. Always exciting. Love the cat facts. And you get a whole bunch of information here along the way, right? There's lots of things to see in the UI and to let you drill down on whatever it is you want to observe. All right, so event-driven workflows here. Events provide this observability, and they really drive our automations. Our automations consist of a trigger and then an action. So that's just kind of our standard language there, and we've been releasing more and more features around this in recent weeks. If you want to make an automation and you're in Prefect Cloud, this is a Prefect Cloud only feature, but Prefect Cloud is free to use unless you need kind of the enterprise features that come with it. And we have the ability to click on an automation here on the side, and you start making an automation by specifying what you want your trigger to be. Could be that a flow run has entered a certain state or failed to enter a certain state over time. And then you can set up an action for it. You could kick off another flow run when something happens or another deployment. You could get notified like I am here through an email. It could be a Slack message, PagerDuty notification, whatever it is you want. All right, so in addition to all those things, we also try hard to have a great user experience. We care a lot about making sure that things are easy to do and that you can get work done that you want to get done as simply as possible. So we have a clear, well-documented API. We have a cool concept called blocks that I'll talk about in a second. They give you some configuration and some code together, best of both worlds. And then we have a fast release velocity. We'll talk about that too, and a supportive community. I have a link there for some more information about blocks. So API, we have a REST API that you can go and have. It's well documented. You can play with that and work with that if you want. We have a lot of ways you can interact with our API. One way is directly through using the REST API if you want. So blocks, we have a Prefect concept called blocks that makes it easy for you to have a form that is just an HTML form that's set up based on your specifications. And then you can work with the results in code super easily. So this is pretty nice because you have the best of both worlds. I think of it kind of like Streamlit, but for the back end. You get this nice web interface, and then you also have the opportunity to just use that code in a nice way. So super nice feature that Prefect offers that you can just use in Python in any way you want. But we find this often very handy for things like credentials and setting up all this configuration so your team can share that information and you can all use it. I mentioned we have a high velocity release cycle. We have releases at least every week, sometimes more often. So this is a feature that allows us to just really keep iterating with a lot of speed. And we have a supportive community. We have over 25,000 folks, or about 25,000 folks now in our Slack community, as I mentioned. And we have a discourse forum where people can ask questions. So we often hear from people that the support that they get is what makes one of the things they love most about Prefect. So I mentioned there's a server and a cloud there. Let's just chat about that briefly because sometimes it can be a little confusing. With Prefect, you get automatic logging, automatic retries, scheduling, notifications, caching, simplified way to have async so that you can just, instead of using the await, async, all those terms, you can just add one term, .submit, and you're automatically using concurrency. It's super nice when you're submitting tasks. We have a whole bunch of integrations, as we'll see in a second, and we try to make Pythonic incremental adoption really easy. You've seen the informative UI, and we chatted a little bit about blocks. So you get all those features no matter what you're using, right? With Prefect Cloud, you get a lot of the things that enterprises really need. So single sign-on, role-based access controls. You have a collaborative UI that you can more easily use with other folks. You can do the same on a free version, but also you get more users on paid versions. Our hybrid model, something that we'll talk about in a second. It's a pretty cool thing. You got all the automations that we saw that are really useful for events, and we can get event logging so you can see what's been happening in your workspace and who's been doing what. It's very scalable, and we have lots of features around security. We built everything with security in mind, and we have a free tier if you want to use it. That's totally fine. You can use it forever, and also self-serve if you want to up things a little bit in terms of features. So I mentioned our hybrid model just very briefly. The idea here is that your code runs on your infrastructure. It doesn't get into our servers. We don't touch it. All that we do is use a little bit of metadata, and we use that to keep track of what's going on with your flows and display that information to you in the UI. So this is a patented model, actually. We got a patent on it not too long ago. And it's something that is definitely very valuable to a lot of users. We have a lot of healthcare users, a lot of fintech companies, and they really appreciate this. Just makes things so much easier when it comes to compliance on their end. And anything in our database is encrypted there. So server, what about, some cases, not everyone wants to have a cloud solution. Why do you want to do that? Some folks might just want to get into setting up, maintaining their own server infrastructure. That's fine. We have lots of people who do that. We have a Helm chart for that. And sometimes you have particular needs that just mean you can't really take your enterprise to the cloud. We get that, sometimes there are lockdown places where you just can't do those kind of things, and that's maybe security concerns of the highest level. That's understandable, and we're fine there. For those folks, just yesterday we announced that we have a Prefect dedicated cloud where even the servers that would be managed by us will run on your infrastructure. So that is a brand new offering and something that might work for some folks. All right, a little bit about how we get here. As most things start in Python land, we're going to do a pip install here with Prefect. You just sprinkle in some flow and task decorators, log in to Prefect Cloud, get some collaborators in there with you, and create a little deployment, and then have an agent that's sitting there polling, looking for work, waiting for it, and we'll kick off work when it's scheduled. We do have integrations with a lot of popular libraries. Over 40 last I checked. So just a couple screenshots here of those. And it's easy enough to use blocks to extend the library. That's part of why we built blocks, is so that it was easy to interface and not necessarily need to fork the repo to do some hacking on it. You can get hacking right away with some blocks. All right, very brief Marvin interlude. Why do programmers prefer dark mode? Anybody? What does ChatGPT 3.5 say? Because light attracts too many data bugs. I think that's pretty good. I would not have come up with that on my own. Is a data bug really a thing? I guess a little weird, but yeah. All right, doing it. All right, so I'm going to go through here some examples of actually using the code and seeing what we get. This is going to be my favorite example. Cat facts are just so educational. Just plain Python. This is what it looks like. You can import requests for HTTPX, fetch. We got a little pipeline here, right? We got this pipe function that calls the fetch cat, and then it calls the formatting because we want to make sure this looks nice, I guess. And we want to call write fact, right? So it's just those three steps and prints out the message after writing the fact to a text file. And we'll get something useful like this. A cat's normal pulse is 140 to 240 beats per minute with an average of 195. It seems kind of high to me. Learn something every day. All right. So if you want to add Prefect to this, how do we do that? Well, just have to add some flow and task decorators, and we'll get some logging right off the gate. So from Prefect import flow and task, add a task, add a task, add a task to each of our small little functions here, and then add a flow to our big function. And we'll say we'd like to log the prints also. You don't even have to do anything else to get the print statements to show up in your logs. Just say log prints equals true, and then you get the print statements. In your terminal, this is what it looks like. We're creating flow runs, creating task runs, creating all kinds of different completing task runs, creating task runs, finishing them, success, everything's good. All states completed. And just realizing here that I took a screenshot before I changed it to actually print out the cat fact. So there would be a cat fact there, I promise, but it's not here at the moment. Everything looks good though. We got some information, and this is helpful when things do not go quite how we expect and we end up with error messages. And these names, we might think, where does this come from? Winged centipede. Yeah, the adjective animal is just a fun way to have unique flow names. If you want retries, this is the exact same thing you just saw. The only thing you need to do is say in your task or flow decorator, retries equals and some integer. That's all it takes. And then in that last example, I did make it into a buggy API because as we know, sometimes APIs are buggy. I happened to make this one so it would fail sometimes. And here we have an example where it's failing. We're instead of just airing out and ending, instead we get a non-final state awaiting retry when proposing a final state of failed, attempting to run again, and boom, it finishes in state completed. Success there. We find out that the cat has 500 skeletal muscles. Humans have 650. All right. More useful information. So next step here, we've got a flow. It's working well. We're just running Python in our script. So it's very easy, right? It's supposed to be should be an easier life than maybe what you're used to if you're trying to debug things locally with Airflow. If you want to take it to the next level, you can put it into a deployment. That's as easy as doing that with one line. And then we can specify where we want the code to be stored, whether it's on AWS, GCP, GitHub, GitLab, Azure, whatever. And where we want our code to run. Do we want to run on Docker, Kubernetes, ECS, whatever? We can define that there also. And then we can schedule things. And scheduling is pretty straightforward. So there's a scheduling. You can do an interval schedule, a cron schedule, or recurrence rule schedule. Any of those are options. And you can do them from the command line, and you can do them from the UI if you like also. So scalability. I showed you earlier that you could scale to thousands of tasks, which is really something that Airflow traditionally has had difficulty with. You can do that here with Prefect pretty simply. Here I've got some flows and tasks, and I am just saying, hey, let's kick off a flow, and let's kick off 1,000 calls of task 1, and we'll also then call 1,000 calls of task 2. So I ran this, and it went okay. I did that by default. It uses concurrency when you're using the map. So we got concurrency really easily right out of the box. And it took about 11 minutes. Took a little time. Took a little longer than maybe ideal. So I tried it with Dask also. It's very easy to scale up parallelizing with Dask or Ray with Prefect. You can run it locally or run it distributed. I was just running things locally for a quick test here. And all I had to do was pip install Prefect Dask, and then from Prefect Dask, import the Dask task runner. And then I can just specify the task runner I want here in my flow was the Dask task runner. That's all I needed to do. Then boom, I have got a whole lot of stuff going on in the UI, and it's going very quick, and I can jump in and check it out. Here's what it looks like to look at task 1, number 400. And this whole thing ran in 3 minutes and 8 seconds. So it works super well. So yeah, question here from Julian I see about the Kubernetes task executor. So yeah, I know so I'm not an Airflow expert. Let me just like throw that out there first. But yes, you can certainly add Kubernetes and scale things out that way also. That's something that's definitely possible with Prefect. So Dask with Kubernetes is something that we see people use often too. I will share a GitHub repo here that has code from today, and I think can't remember if it's in there or not, but we do have examples of using Kubernetes also with Dask. All right, well, Marvin interlude. Why do data analysts like looking at pie charts? Anybody? Because they're sweet and delicious. All right, I don't know. That's what ChatGPT says. I don't know that they're actually delicious, but it's what you get with AI. All right, so talking about transitioning from Airflow a little bit here. I think according to time, I've got just a couple minutes left, so I will keep it brief. This is the Airflow DAG view that you perhaps know and love. And there are a couple examples here that just to show you that things are running. We have a couple options for getting going with Prefect very quickly. You can have Prefect have an Airflow DAG and have Prefect look at it by making a couple of events and just tracking things that way, so that they also show up in the Prefect UI. So here is the Airflow code. We've got the Python operator in there. And we are just doing some very basic calling of some functions here. All it takes to get Prefect to be able to observe this is from prefect.events, import emit event. And now when your DAG gets started in Airflow, we will have a notice of that. And we'll have another emit event when it finishes. So that's all it takes. And here in the event feed in the Prefect UI, you can see that we have at 10:10:29 last night, there was an Airflow DAG that finished, and it started 10:10:26 just before that. So this can be helpful if you are looking to have a team and kind of bring things over to Prefect. You can just start observing the information right away. Similar and maybe just slightly more information being captured here if you want to actually turn these into flows also. We have another example, and again, this will be in the GitHub repo, where you have, we're looking at energy production information, doing some work with that. This is the first part of this, and the second part is here. All it takes to get that information into Prefect is to add the flow decorator, and I also had here that we would log those prints. And then in Airflow, you see that things are happening as you expect. In Prefect, we see that we are actually capturing this information as flows also. These are individual flow runs that are showing up in the UI. All right, so just a few quotes here from folks. We have lots of customers, and here's a couple of things, nice things I had to say about Prefect and a lot of these folks moving from Airflow. Go from thought to production 5x faster, cutting down time spent on errors 75%. Prefect making our lives easier, addressing lots of pain points with more complicated tools like Airflow. So advice, and this is always, I think, the advice from everybody here is use what's working. If you have something that's a good solution, just go for that for sure. But if you need to scale, you need some more flexibility, you need to have some observability across your stack, or want to move more and more into an event-driven workflow place, or want a UX that's really easy for folks to get up to speed with and a little easier, then I encourage you to check out what Prefect has to offer. So at Prefect, we try to observe everything and say that you can orchestrate anything. If you want to learn more about how to use Prefect, we have a couple of training opportunities. One coming up in San Francisco, one coming up online here. Those are selling out fast, so do check both those out. London is almost full, but that's the closest one to Paris. But if there's more interest, let me know, and we can potentially look at opening up other ones in Europe in the future. I got a discount code here for 20% off any training opportunities, so do check those out. And then, you know, the one more thing with Apple works better if you haven't really mentioned it all, but very briefly, I do want to just show a few things with Marvin here. So this batteries included library for building AI-powered software. It does have a lot of cool features. One of them that's really nice once you've installed Marvin is AI functions. This is just kind of mind-blowing, so I'm just going to show it for a quick second here. Just decorate your function with @AI_FN, and then tell it what you want. So in this case, I just told it what I wanted in terms of the inputs and output types, and told it to generate a list of fruits. And then it calls OpenAPI and sends back that information. And does not write code or anything. It is just going and asking and finding out what that information is, and doing a few things behind the scenes to make it a little more usable. But that is what we get back: a list of 20 fruits. So just one more example here. If you want to see a little spam detection, just tell it that you want a number back, how likely an email is spam, and the input being, hey, just following up about dinner tomorrow. Or a second example, hi, I'm your CEO and need you to go buy gaming gift cards. What do we get back in those cases? I got back 45 the first case and 95% probability in the second case. So yeah, pretty good. I think that's probably right. We probably agree with that. So again, Prefect here. We've got tools for interacting with complex systems. Lots of systems where state is changing and it's hard to know what's happening on the inside, and we want to be able to observe those and be aware and interact with those. So we've got the Prefect library for that, and we have a very new hot product, Marvin, that is this batteries included library for building AI-powered software. So we think of them as kind of two sides of the same coin. Thank you.
Thank you so much, Jeff. I think we are out of time, but we can maybe you can answer maybe the question by chat afterward. But perfect. I had one question I wanted to ask you before going to Dagster presentation, because I asked the question to everyone in the first part. My question is, because it's like an Airflow meetup and the idea is like to talk about Airflow alternative. My question is, how do you see like the competition, I say between quotes, with Airflow, and what's your vision like in the next years? Do you want to replace it? Do you want to live together? How can it work? And if I just add something on it, I remember I talked to Jeremiah, your CEO and founder, like maybe 1 or 2 years ago. I don't remember very well. And at this time, the market positionment of Prefect was for data scientists, like having like a light library where you can just add decorators on your data science code to our flows. Is it still the same? Do you still address the same market, or do you want to go large?
Yeah, it's a good question, especially when terms like data scientists get used so differently by so many different people. It's a little tricky. I mean, our core users right now of our product are data engineers and machine learning engineers. Sometimes there's a lot of overlapping circles in the Venn diagram with data scientists on that. But I think if it's sense that a data scientist is more looking at analytics and building models, we're seeing more use from people productionizing models and data engineers moving the data around. But there's something we kind of have a feeling internally that a lot of things are data engineering with different terms behind them, perhaps.
Yeah, that's true.
So I think that's where we are focusing a little bit more these days in terms of our core persona, a little bit less so maybe the analytics engineer or something like that. Yeah, and I think Airflow's big and not going to disappear for sure. I think we all say that, and we all think that there are opportunities there. But as I think I alluded to in a few places or stated outright, I think there are good reasons when you want to try to scale things, or you just want to have an easier time doing certain things, that it can make sense to look to Prefect, especially with more and more observability coming down the road and more event-driven options. So I think there's a future for everybody. If it seems like I don't have historic data on like downloads, I was only able to go back 120 days or so, but seeing that we're now over 10% of what Airflow is, and if that 5.5% from Seattle data guy was representative a while back, like I don't know that those are a little bit apples and oranges numbers, but I think I think everyone who you're invited here is happy to take a little market share from Airflow, but it's a big pie and it's expanding, I think. So I think there's room for everyone to play.
Yeah, that's true. And also there are like other private kind of orchestrator that no one mentions, from IBM and all the old companies, where we can grab market share when we are like open source tools, I guess.
Totally. We often say, people trying to just make their own orchestration systems also by hand is still a big part for everyone to make their lives easier. So absolutely. Thank you, Christoph.
Thank you so much, Jeff. It was like a great presentation. I hope like the chat thank you again. We will move on to the next presentation from Tim from Dagster. Maybe you have a last word.
Thank you.
Hey, Tim. Do you hear me? Not sure we hear you yet.
Sorry, can you hear me?
Yes, it's working.
Cool. Okay.
Hey. Okay, the floor is yours. Maybe you have to share your screen. I don't know. I will add it to the scene. You can go.
All right. All right. Okay, let's get started. Hi, I'm Tim, and I'm a developer advocate for Dagster. We have a couple engineers from the Dagster team in the chats, and they're ready to answer any questions you have. So feel free to send them during the presentation, and we'll try to answer them as we go along. Now, before we start, we do have to give credit where credit is due. Airflow was the pioneer for managing data workflows and really set the standard for how ETL and orchestration worked. It enabled people to move beyond cron jobs by modeling a graph of tasks and executing them on a schedule. It made understanding the dependencies between scripts and computation really easy. And it was also the first Python-based workflow engine to have a full web interface. So rather than grepping or querying through your logs, you had a UI that you could use to slice and understand what you're looking at. And given this and so much more, it has been the most popular tool for almost a decade, and it would be rude of me not to acknowledge any of that. But being the first does not mean that it will forever be the best. As time goes on, software and business problems evolve and become more complex. New paradigms and software build on the lessons of the existing software. And they stand on the shoulders of these giants, leveraging the lessons and best practices that the existing tools discovered. And we believe that Dagster is that next iteration for data orchestration. Dagster builds on some of Airflow's strengths while working to resolve key challenges in modern data engineering. Over the next half hour or so, we're going to be talking about Dagster and what lessons we've learned from standing on the shoulders of Airflow. This includes things like dependencies between computation, retrying runs, and concurrency limits. And I know that I'm talking to a room full of people familiar with Airflow. So I'll be using Airflow's capabilities to compare and contrast functionality of Dagster to help explain how Dagster is different. And to add to the disclaimer, yes, some of these things can be done with Airflow, but you'll often find yourself working against Airflow rather than with it in order to get them implemented. Dagster provides everything that we'll mention out of the box without any additional effort. The end result is that you'll focus more on the data pipelines rather than working with the boilerplate or infrastructure around the orchestrator. Let's begin. Airflow is primarily a task orchestrator, and Airflow DAG is a workflow of tasks connected by dependencies, which are other tasks. Airflow recently introduced a dataset abstraction. However, it's not a fundamental building block for the Airflow experience. By comparison, Dagster sees the goal of a data pipeline as producing data assets, like tables, files, or machine learning models. Dagster's programming model and user interface are all built on that abstraction. To go more into what I mean when I say this, when I say that the goal of a data pipeline is to make data assets, is that when you make a data pipeline, you're already writing data back to storage. Airflow focuses and is aware of only the computations, otherwise known as tasks and operators, which are the purple boxes on this diagram over here. However, Dagster is aware of your entire data pipeline, including the data assets that come out of those computations. This gives you a more complete view of your data pipeline rather than just the computations that happened. Now, let's drill in deeper about why it's so important for you and your orchestrator to be aware of your data assets. The main reason that people build data pipelines is to create and maintain these data assets, like tables, files, machine learning models. Your teammates and your stakeholders think, talk, and use the outputs of these pipelines. To wrap it up, people don't care about what tasks were run. They care about the data assets that came out of them. This is why your orchestrator should be aware of your data assets. By being asset aware, you get to understand all of your data pipeline and not just the computations that happened. An orchestrator that includes your assets as a central part of its data model enables more straightforward debugging, more natural APIs, and a deeper, more powerful integration with modern data stack tools like Fivetran, dbt, and Airbyte. It also enables you to create integrated lineage and data observability into the UI. While you can only track computational lineage in Airflow, Dagster tracks data and computation dependencies to create this fuller lineage that understands both what computation happened and the assets that came out of it. Now, thinking in assets also allows you to create a clear relationship between your computation and your data, reducing the amount of code written. As an example, here's a comparison of the same data pipeline written in both Airflow and Dagster. The pipeline has one data asset that's made out of another data asset. With Airflow's APIs, you need to tell Airflow that the task that's building the second asset should run after the task that's building the first asset. But then you also need to read in the first data asset in the second task. It's a lot to keep track of, and it's brittle. Now, on the other hand, in Dagster's APIs, you just express a dependency between the assets in one place. Also note that if you wanted to incorporate Airflow's datasets abstraction into the Airflow example, you'll have to write even more code on top of this. Now, Airflow was written before many current software engineering best practices were figured out or widely adopted, one of which was pushing testing to developer environments. With Airflow, many organizations are pushing code changes straight to production to test them out. Since then, organizations like Astronomer have made an incredibly noble effort to fix this, but there isn't one cohesive, consistent way that everyone can use. Dagster was built from the ground up with these best practices in mind. Our system was structured to be able to build and test everything from your local environment. And we try to show it. Dagster can run and test at every stage of your developer workflow. Running Dagster locally is as simple as a pip install Dagster, and then running a single command, Dagster dev. You can now have Dagster run in CI for you, or you can use Dagster Cloud to automate creating temporary staging environments that you can share and collaborate with your team. So by the time it reaches production, your data pipelines will have already been tested thoroughly, and you will have less bugs because of it. Now, to really go into how Dagster can provide a strong development lifecycle, we can talk about how you can separate the business logic, storage, and environment. With Airflow, your environment that it runs on is tightly coupled with its storage. You can hack together with dynamic querying to figure out whether you're on local or production, but that is more boilerplate and overhead to manage. And it creates more knowledge to transfer as people onboard to contributing to your data platform. On the other hand, Dagster makes it easy to write data pipelines without coupling them to any specific environment. This makes it possible to run them in a variety of different contexts. For example, Dagster makes it easy to alter the behavior of your pipelines depending on which environment it's in. A pipeline can interact with a mock version of Slack when running in a unit test, or it can communicate with a production Slack instance when running in production. Dagster also makes it easy to separate your business logic from your storage. A pipeline can write to DuckDB when running locally, to data frames to memory when executing within a unit test, or store them in Snowflake when running in production. And this execution is pluggable at a very fine-grained level, which means that you can take a job that runs distributed across a Kubernetes cluster in production and run it within a single process when you're running it within a single unit test. Now, once again, got to give credit where credit is due. Airflow built out a very robust model for scheduling because running at a certain time was the primary problem they had to solve for. It also incorporated sensors at some point. Dagster's runs are flexible and can be started through various different ways, including schedules, sensors, and an API. However, it also enables users to start runs based on service level agreements, or SLAs, of their data. We've seen that our users don't care how often a script is run. They care that the data is up to date and meets the SLAs that their stakeholders need. In Dagster, you can define what it means for an asset to be out of date. And when it is out of date, it will find all the upstream assets and run as needed. This enables you to think about more than just schedules. Instead of thinking in schedules, Dagster allows you to think about not just how often to run a pipeline, but also how often an asset needs to be updated, or what events should trigger a run. Maybe your stakeholder doesn't need a report to run every 4 hours, but rather promise that it's accurate up to the past 4 hours of data. Or maybe it should only attempt to update when its upstream dependencies have changed. In the end, what matters is that this saves you time, overhead, and money because your assets are only updated when they need to be. Now, this last one sums up a lot of what we've talked about. You can do a lot in Airflow. We have to give it the credit. But it also requires a lot of extra effort and infrastructure and maintenance at times. Let's take data lineage and metadata, for example. With Dagster, you don't need to integrate with other tools or annotate your tasks to get data lineage. By properly connecting your assets together from the get-go, you get that full end-to-end view of your entire data platform right out of the box. Now, after you've written your data pipeline, you typically use your orchestrator's web UI to monitor it. Airflow's UI is primarily concerned about what tasks or computations were run. Dagster's web UI also focuses on the data values produced by those operations. It makes it very easy to include metadata about that data and track how it evolves over time. In this example, you can see how many rows a machine learning model has, where it is in S3, and how it has performed over time. By creating a platform that is asset aware and focused on metadata upfront, you can add even more complex metadata, such as embedding previews of the data as tables, or adding plots and data visualizations directly into your orchestrator. Okay, now that you've heard about the key differences and got an introduction to Dagster's concepts, let's write a basic pipeline and then give you a glimpse at how much more you can do with Dagster and its asset-based framework. Before going into it, let's set the scene. You are part of a data engineering team that wants to do some reporting on the populations of countries and continents across the world. And let me just switch my screen share. Now, I'm going to skip the scaffolding of setting up a project, installing dependencies for the sake of time, and go into actually writing the pipelines. But you'll just have to trust me that it's as simple as pip install Dagster. I'm also running on Python 3.9 purely because of inertia, but Dagster does work with 3.11. Now, let's build our first asset. We're going to grab data from Wikipedia and write it into storage. Now, what I'm going to do is make a data frame. that uses Pandas' read HTML method, which if you haven't used it before, it queries for an HTML page and just grabs the first HTML table out of it. Then I'm going to say specifically which columns out of that table that I want, and then just return the data frame. At the end of this, after I've made this purely Python function that is very familiar to a lot of people, I'm just going to add the Dagster asset decorator on top of it. I just want to drill down that adding the decorator is all you need to do to tell Dagster that this Python function is how you want to define an asset. And then by default, the data is stored on a local file system as a pickled file, but later we'll show you how to write to databases or cloud storage. Now I've already started running Dagster dev, and I'm just going to flip over to it right now. Window. Minimize. All right. Okay. And let's hit reload definitions. Oh, did I hit save? I didn't. Okay. Reload. All right. Here you'll see that individual asset on what Dagster likes to call our asset graph. As we build out this project, you'll be seeing more, and you'll see how this builds out a full, comprehensive end-to-end DAG of your entire data pipeline. Now let's materialize it, which is Dagster's way and term for running the computation that creates a data asset. And you can see that it's now updated. And that's all it takes in order to build an asset, and that's what it takes to make an asset happen. Now I'm just going to flip over back to VS Code.
When you switch, Tim, I switched directly like from Melon.
Sorry, well, did you already switch to VS Code?
Yeah, I switched.
All right, appreciate it. Thank you. All right, cool. Now let's add the next asset into this. Let's say that now we have the populations by country, and now we want to aggregate by continent. To do this, we first need to know the populations by country. Thankfully, we already have a data asset with that. So we will be dependent on that country population asset to create the continent populations. Let's bring this asset over. And now you can see that one of the ways you can define dependencies in Dagster is by using the asset name as a parameter. There are more programmatic ways to do this, but this is the simplest way in Dagster. You'll see that it takes a data frame, groups by it, sums it, and same old pattern, returns that data back out of the function, and now you should have an asset. Now I'm just going to flip back over to the UI. Christoph, you're really good at this. I'm impressed. Once again, I need to remember to hit save. Cool. And now you can see that your asset graph has changed. Now you can see that out-of-the-box lineage that I've been hyping up over the past 20 minutes. And you'll also notice that continent population is marked as stale. That's because the upstream data has changed. So now continent population might be out of date. So let's just hit materialize all to see everything. And there you go. Now, this was just a brief little demo of the core concepts of Dagster. But let's also show you how some of the other things you can do with Dagster can look like in real life. I'm just going to flip a file really quickly. There's no need to change the screen share yet. So Okay, and then hit reload. And now here is a much more larger, complex, more intricate, more varied asset graph that Dagster supports. We just jumped into the future and built out more of its project. And let's dive more into what these changes are. First of all, the obvious one is you'll see more assets. Now, hypothetically, let's say your data scientist wanted to build out a forecasting model out of the reports you made. And so here are the assets that they use to build out the features for their data. And then here is the machine learning model that they trained. And then here is the report of all the forecasted populations that came out of that machine learning model. And then on top of that, another team, your analytics engineers, they want to do even more granular, more high quality reporting on top of your data using dbt. Now, integrations of Dagster embrace Dagster concepts. For example, of dbt, every model in your project is treated as individual assets, which is how this dbt project got expanded into this set of assets over here. You'll also see that now assets have tags associated with them, such as these assets are from dbt, these assets are stored in DuckDB, this is a Python function, or that this data came from Wikipedia. This is an example of metadata that comes when you define an asset in Dagster. Now let's click on an individual asset, such as country population. You'll see that not only does it have a description, but it also has a row count, an overview of the columns in the data frame along with their data types. And let me materialize this one really quickly. And here we go, a preview of your data asset. Now you'll notice, now if we zoom out again and look at the other assets, you'll see that some of these assets are partitioned. You'll note by how it says 3 partitions over here and has a slightly different UI. These features are partitioned by the date column and are split on a daily partition, as you can see from here. Now, this partitioning is persisted into storage, so you can always query the data by its partition. And since partitions are tied to data assets and not the task running it, backfilling in Dagster is a very smooth process because you can backfill by slices or individual partitions. Now, we'll also look at a little bit about the SLA-focused scheduling that I mentioned earlier. If I click on the forecasted population, you'll see how it says that it should have all data up to 24 hours before that time. So once it hasn't run with up-to-date data in 24 hours, it'll get marked as stale. And then Dagster will update itself and all of its upstream assets. Now let's head over to the overviews, and you can see your projects, your ad hoc materializations. You can also look at the jobs you have, what schedules you have set up. We also support sensors. Here's that UI and experience we were talking about backfilling, in which you can just select individual slices of partitions to backfill them. And then if you wanted to, let's flip over to the runs tab to see our historical runs. If we look at an individual run, we can see all the logs that happen to it, along with any metadata that it emits. All of this data can be retrieved via Dagster's GraphQL API. And that's Dagster for you. Now I'm just going to flip back over to the presentation. There we go. If this interests you and you'd like to try out Dagster, we likely integrate with most of the tools you use, ranging from ingestion, such as Airbyte, 5chan, or Meltano, to transformation of dbt, or monitoring with Datadog and Prometheus, or with your data warehouses like Snowflake and BigQuery. Integrations are aligned with Dagster's concepts, as we showed earlier by expanding the DBT models into individual assets. You may even notice a certain familiar logo in here. We've had many users come from Airflow because they were interested in the functionalities and the features that we've talked about Dagster. And with this, we built out a utility called Dagster Airflow, which has functions to help you run your Airflow DAGs within Dagster. Now, the two things we want to call out is these two functions, make Dagster definitions and load assets from Airflow DAG. The first one is a function that you can point to a directory of your Airflow DAGs, and it will translate them and run them within Dagster. So you can just point it to your entire Airflow instance and have it running within Dagster. And the other one is when you're ready for a more granular, more piece-by-piece migration, you can load in an individual Airflow DAG and start thinking about assets and start thinking about how your computations map to your assets by creating a map between assets and the tasks that generate them from your Airflow project. Now, if you're skeptical about this, that is completely fair game. But here's an anecdote of how a user was able to run an Airflow DAG and Dagster locally within 4 hours, and then moved all 73 of their organization's DAGs within 3 days. The social proof doesn't speak any better than that. So that being said, if you'd like to try out Dagster, we already have resources ready for you. You're welcome to join our community and our Slack to meet with thousands of other Dagster users. You can discuss architecture or ask questions. If the community doesn't give you an answer, someone from the Dagster team will get back to you. We also have our documentation that's available to you. Or there's a 10-minute crash course that our great Sean has made to about setting up a Dagster project. And if you want more details about moving from Airflow to Dagster, we have guides, we have blog posts, videos, and example projects to help you do that with our utility package. And just to really bring it all back up to the top, these were the key differences that you learned between Airflow and Dagster. And to take away from the 3 key themes of what your data orchestrator should do is that it should understand about the computations and the data assets that come out of it. Because by doing that, you get better observability, debugging, and lineage. And your orchestrator should work and respect the software development lifecycle, from local development to CI and staging, all the way to production, by separating your logic from the storage, which enables you to have easier and better ways to test your pipelines. All right, that is it. Thank you for your time.
Thank you so much, Tim. I really like the presentation. Maybe people have some question in the chat. I've seen that people from your team already answered some of the questions. So I will start with one question because we have 5 minutes, roughly 5 minutes. So I will start with one question. And if people have other questions, please type it in the chat. So my first question is, how do you position like Dagster in terms of competition against Airflow? How do you see Dagster in 1 year, 2 years? Do you think like, do you want to attract people from Airflow? Do you think you will kill Airflow at some point?
Okay, I'll phrase this as we are all trying to solve different problems. And Dagster is trying to communicate that the problem that people are trying to solve is data pipelines. And each of these different tools have their own strengths, and we aren't trying to replace task orchestration. We care about data pipelines, and we always will. Or in 1 to 2 years, like our core users are the data engineers who want to use the software engineering best practices, who care about the data pipelines, who care about their stakeholders and getting and reaching data SLAs. By effect, Dagster is also aimed at your data scientists, your analytics engineers, and your ML engineers. But at the end of the day, our core persona is the data engineer who cares about the data pipelines. So that is the slice of that massive pie of orchestration that we are trying to focus on.
Okay. This is fun that you say data engineers who cares about data pipeline, because from Dagster vision, like the data pipeline is not like at the core. This is like the asset that is at the core. And the notion of data pipeline is, I feel, a bit hidden, which is not a bad practice. I think like the Dagster vision about asset is really good, but this is like a different way to approach the data workflows, because like the pipeline are really hidden, like the runs, everything is like hidden. You just see the asset in the program. So yeah, I don't have any question. This was like a remark.
Oh, thanks for sharing your observation. Yeah.
Yeah, and also one point about the vision. I think among all the orchestrators, you have like you are like, I think, the orchestrator that does the most innovative vision, I would say, regarding like especially like the assets. But I think with data sets, Airflow is trying also like to pick up. Don't you think that other alternative will pick up, and Dagster like unique way of thinking will not be that unique? And how will you like compete with like people copying like the event-driven scheduling, I would say?
Well, first of all, I'm probably excited to see more people copy event dribbling and data asset focused orchestration, because that's just more validating proof that we're doing it, that we're focusing on the right things. And
yeah.
Second of all, just at the end of the day, we are still going to have the brilliant minds behind Dagster working and coming up with these new innovative concepts and features and really constantly pushing the envelope. So we do get the advantage of, as time goes on, we are going to continually innovate and create and understand this problem space better.
Okay. There isn't any question in the chat. I had one regarding like the global asset lineage web UI. This is probably like the question we should ask to everyone. Does it scale to thousands of nodes?
So there is a degree in which like just rendering things is does become a little difficult. However, like we're always constantly iterating and working on trying to figure out how do we scale our UI better. And so, but we always recommend a way to reframe the problem of what are the different projects that you're thinking about? How do you segment your different assets across different projects? Is this actually 100 assets, or is this one asset with 100 partitions? So that's part of the Dagster Slack community. That's part of the Dagster team. Always trying to think about, well, how do we properly look at this, and how do we properly represent our assets?
Okay, got it. There is one question from Alexandre. Do you think paradigm shift from workflow design to asset-based design might be a barrier for the team to move to Dagster? This is a significant paradigm shift.
Well, I will acknowledge, like, it is a very fundamental. It is an interesting, more specific way to view the problem. However, like, the Dagster team is here, the Dagster community is here. Like, a lot of our marketing and a lot of how we frame our APIs help you try reframing that the tasks that you've always been orchestrating, they've always been producing assets, and we just try to show you how to focus on the assets and not just on the computations. Yeah, if you look at that, like, if you look back to that pipeline slide I had earlier, just the assets were always there. It's just no one ever actually knew they needed to focus on them. And that's what a lot of our marketing and a lot of our demos try to focus on.
Yeah, I agree. You're right. Okay. I have one last question if no one has. My last question is about pricing model, maybe, or business model. So you are like an open source tool, but there is like a commercial company behind. How do you price the tool, or do you price the cloud?
Yeah. So, okay. As mentioned, like, yes, we are an open source tool. However, we do have a managed cloud offering. That managed cloud offering has two different deployment options. One is just serverless, in which we'll just spin up and do all the compute for you. The other is hybrid, in which you deploy an agent onto your end, and the only thing that Dagster Cloud gets is your logs and your metrics. Really helps when you need to worry about security, or you need to stay in compliance somehow. And pricing is typically structured around how long your compute is going for, and how many computations and how long your computation is going for.
Okay. Okay, lovely. There isn't any question. I think we are done with the time. I let you like the last word, and then I will conclude the event.
All right. No, thank you for the privilege of the last word. I mean, I guess, yeah. All I have to say is, yeah, Airflow is amazing. Like, it has given a lot of people jobs. It started off a lot of people's careers and really helped redefine how people approach data orchestration. And Dagster just wants to build on top of those shoulders and that platform that Airflow has built. And that we just want to help be that next iteration, that next evolution, that people can focus on data pipelines. Yeah, thank you.
Okay. Thank you, Tim. It was a pleasure to have you. I'm so happy to have seen like a demo of Dagster, and I'm so happy to have you today. Thank you so much, and see you. Okay, we are done for today. Thank you all for watching and to have participated to this event today. The replay gonna be available on YouTube just after the presentation. The record has been done. I will also like slice all the presentation to have like 4 shorter videos about like all the presentation we had from Prefect, Dagster, Orchestra, and Maj. Thank you so much. It was the last part. Maybe we're gonna do a part 3 if other orchestrators are coming and people wants to see something else. But I think we are done for this first batch of orchestrators. Don't forget to join the Paris Apache Airflow Meetup page on LinkedIn. We just created it recently. And thank you all and see you soon. Ciao, ciao.